For generations, humanity has looked to the stars with a mixture of wonder and profound solitude, questioning whether we are the sole authors of our cosmic story. We have studied the planets, charted the galaxies, and sent our mechanical emissaries into the void, all while listening to a silence that seemed eternal. But that silence was broken, not by a radio signal, but by a visitor. For months, astronomers believed they had finally categorized this messenger, a frozen relic from another star, a comet older than Earth itself, drifting through our solar system on a one-way journey. Designated as only the third interstellar object ever discovered, 3I/Atlas, was a cosmic courier, promising to deliver secrets of chemistry forged around an alien sun. It was a rare prize, a once-in-a-lifetime opportunity for science. But then something happened. Something so violent, so sudden, and so fundamentally inexplicable that it forced the world's leading astrophysicists to hesitate, to double-check their data, and to question the very foundations of what they thought was possible. According to a groundbreaking, peer-reviewed analysis led by Harvard astrophysicist Professor Avi Loeb, 3I/Atlas did not simply swing past our sun. It may have undergone a catastrophic structured explosion, shattering into at least 16 separate fragments right at the peak of its solar encounter. And the most chilling part of this discovery is not the fragmentation itself, but the evidence that suggests this was not a chaotic, natural breakup. The data points to something organized, geometric, and almost controlled. This is the story of how an object born in the crucible of another star system may have actively transformed or torn itself apart right before our eyes. If the data is correct, we are not merely documenting a celestial event. We are witnessing something unprecedented in the annals of modern astronomy, the real-time death, or perhaps the deliberate transformation of an interstellar traveler. Tonight, we are diving deep into the shocking numbers from NASA's tracking systems, the pristine infrared scans from the James Webb Space Telescope, the stringent diameter limits from Hubble, and the jaw-dropping images from the British Astronomical Association to answer two haunting questions. Did 3I/Atlas truly fragment? And does the pattern of those fragments suggest a natural phenomenon or something far, far stranger? Because once you see what the world's most powerful telescopes captured in the early November of this year, you will never look at a passing comet the same way again. The story of 3I/Atlas begins with an air of innocent discovery. On July 1st, 2025, the Atlas Asteroid Terrestrial Impact Last Alert System survey telescope in Chile pinpointed a faint, new object drifting into the inner solar system. Initial calculations of its hyperbolic trajectory, its extreme speed and path, confirmed it was not bound to our sun. It was interstellar, only the third such object ever confirmed, following the enigmatic Oumuamua in 2017 and the more comet-like Borisov in 2019. The scientific community was electrified. Here was a new sample from a distant stellar forge. In late August, the James Webb Space Telescope, JWST, turned its golden eye toward the visitor. Using its ultra-sensitive NIR spec, near-infrared spectrograph instrument, Webb made a startling discovery. 3I/Atlas was already active, sporting a colossal coma of carbon dioxide gas stretching an astonishing 348,000 kilometers across, a distance nearly equal to that from the Earth to the Moon. While exceptionally large, this activity was initially chalked up to the exotic nature of an interstellar comet. However, buried within Webb's spectroscopic data were the first subtle anomalies. The ratios of certain metals like iron and nickel were off. The molecular signatures didn't perfectly match the expected patterns of solar system comets. The prevailing explanation was simple interstellar exoticism. This object was built from different materials around a different star. It was simply different. But as September turned to October and 3I/Atlas hurtled toward its closest approach to the sun, its perihelion, the real anomalies began to emerge, shattering the comfortable narrative. As Atlas neared the inferno of our star, tracking data revealed something deeply unsettling. The object wasn't just falling under the sun's gravity, it was inexplicably speeding up. Precise measurements, meticulously tracked by teams at Harvard, revealed a radial acceleration of 1.1 times 10 to the minus 6 astronomical units per day squared, and a transverse acceleration of 3.7 times 10 to the minus 7 astronomical units per day squared. To translate this from abstract math into breathtaking reality, this resulted in a cumulative velocity increase of a staggering 94 kilometers per day squared at perihelion. Consider this. 3I/Atlas was already traveling at a mind-numbing 150,000 miles per hour. Yet it found a way to add even more speed, as if pushed by an invisible hand. In standard comet physics, the only logical explanation for such non-gravitational acceleration is outgassing, the sublimation of ice into gas, which acts like a natural thruster. But if outgassing were the cause, the calculations showed that Atlas must have been losing unimaginable amounts of material. And this is precisely what the data began to show. Between early August and late October, the calculated mass loss rate exploded from a manageable 330 kilograms per second to a nearly unbelievable 2 million kilograms per second, a factor of 6,000 times increase. This is the moment the alarms began to blare across the global astronomical community. This is where the math stopped making sense. Even for a comet under intense solar stress, this jump is absurd. It would be like an ice cube suddenly transforming into a volcanic geyser. Something was happening deep within Atlas's core. Something was building, pressurizing, and preparing to unleash itself. Then, adding to the mystery, the comet began to glow with an unnatural electric blue hue, a color not typical for simple reflected sunlight on dust, but one that often indicates the presence of ionized carbon monoxide gas or incredibly high-energy processes. Astronomers knew the moment of truth was fast approaching. What happened next is where the entire conventional cometary explanation collapses under the weight of its own contradictions. At perihelion, the sun delivered a blistering 700 joules per square meter per second of energy to 3I/Atlas. For the comet to sublimate enough ice to explain the catastrophic mass loss rates, physicists calculated it would need a total surface area of approximately 617 square miles. This is equivalent to a solid sphere with a diameter of about 14.3 kilometers. There was just one monumental problem. The Hubble Space Telescope had imaged the object's nucleus just 3 weeks after its discovery. Its analysis was unequivocal. The nucleus could be no larger than 1 to 2 kilometers across. It was not even close, a discrepancy of 16 times. This left only one inescapable conclusion. Either the comet physically grew in size, a physical impossibility, or it shattered, exposing vast new interior surfaces to the sun's heat. This is the precise moment Professor Avi Loeb and his team entered the fray with their extraordinary realization. Loeb posited that if 3I/Atlas had split into 16 distinct fragments, each new piece would present its own fresh surface area to the sun. The combined surface area of these 16 fragments would match the required 14-kilometer value almost exactly. The math was perfect, eerily perfect. 16 fragments equaled 16 times the surface area, precisely the number needed to resolve the insane mass loss readings that had baffled everyone. This was not mere guesswork or fringe speculation. It was cold, hard, publishable astrophysics emerging from one of the world's most prestigious institutions. And so on November 10th, Loeb's team released their analysis. 3I/Atlas had likely exploded into at least 16 pieces. But the Harvard paper introduced a darker, more provocative question, one that scientists are trained to avoid without overwhelming evidence. What if the breakup wasn't caused by passive solar heating? What if it was triggered by a mechanism inside the object itself? The plot thickened immeasurably in the days that followed. Conventional wisdom dictates that when a comet breaks apart naturally, it should create a chaotic cloud of disorganized debris, random plumes, and uneven, hazy gas clouds. But that is not what astronomers witnessed. On November 9th, British observers Michael Butler and Frank Nickling captured a set of photographs that would change the entire conversation. These were not simple amateur snapshots. They were high-precision, professionally processed astronomical images. The pictures revealed something breathtaking, an anti-tail, a stream of dust pointing toward the sun, a rare and counterintuitive phenomenon that was perfectly organized. Alongside it were main columnated jets of material stretching an incredible 2.85 million kilometers into space. This was not random debris. This was geometry. This was directional organization on a colossal scale. The very next day, a separate team of astronomers, Jaeger, Raman, and Pospieszalski, confirmed the finding, capturing at least 7 distinct jets, all aligned in a coordinated, symmetrical pattern. Natural fragmentation looks messy and unpredictable. This looked engineered, almost like a series of controlled thrusters firing in sequence. Loeb's calculations further complicated the picture, showing the comet was shedding an almost incomprehensible 50 billion tons of material per month. Yet the fragments themselves remained coherent and stable. Something powerful and focused was driving these jets, and it bore no resemblance to the passive, diffuse process of ice sublimation. Faced with this mounting evidence, some astronomers attempted to find solace in known phenomena. Comets do fragment. We have witnessed it before, with comets like 73P/Schwarzmann, Wachmann, and even our own NEOWISE displaying strange behavior. But natural fragmentation always leaves specific fingerprints: a gradual rise in internal temperature, the propagation of cracks through the nucleus, uneven mass ejection, diffuse and hazy debris fields, and chaotic jets spraying in random directions. 3I/Atlas displayed none of these hallmarks. Its jets were clean, straight, columnated, and aligned with mathematical precision. It was like watching a well-choreographed ballet, not a building collapsing. Advanced thermal modeling showed that the internal temperature of a nucleus, its size, should never have reached the threshold required for such a catastrophic and instantaneous breakup. The timeline was wrong. The physics didn't match. The patterns were an utter mismatch. The official, conservative explanation remained natural breakup, but the evidence was pushing back with immense and growing force. It is at this critical juncture that Professor Loeb introduced the hypothesis he knew would ignite global controversy. He argued that if natural comet physics cannot explain the mass loss, the anomalous acceleration, the organized jet structures, the sustained symmetry, and the fundamental surface area problem, then the scientific method itself demands that we consider alternative interpretations. His exact wording, drawn from his publication, is crucial. Technological thrusters can achieve much higher exhaust velocities than natural sublimation. This means that if Atlas were an artifact of non-human technology, even a derelict one, the fuel requirements to explain its behavior would be minuscule. The mass loss patterns would match the observations. The jets would appear columnated and controlled. The perplexing anti-tail could be an intentional directional release. The anomalous acceleration would be trivial for a designed object to achieve. Loeb is not claiming it is definitively a spacecraft. He is performing his duty as a scientist, insisting that we must follow the data wherever it leads and remain open to every possible interpretation, no matter how paradigm-shifting. For the first time in history, a leading Harvard astrophysicist has formally published a paper stating, for the world to see, that this interstellar object might not be natural. As of the latest data on November 11th, 3I/Atlas has re-emerged from its solar conjunction, having passed behind the sun from our perspective. Now, for the next 7 weeks until its closest approach to Earth on December 19th, humanity has a once-in-a-civilization opportunity to observe it. This is our final chance. The Hubble Space Telescope is scheduled to perform intense ultraviolet spectroscopy, probing the chemical composition of the fragments. The James Webb Space Telescope is already analyzing molecular emissions from the persistent jets. Mars orbiters reportedly captured valuable data during the solar conjunction when Earth-based telescopes were blinded. Every major observatory on our planet is on full alert, their instruments trained on the 16 departing pieces. Whatever 3I/Atlas truly is, a fragmented comet, a geological relic from another system, or something intelligently engineered, we are watching the truth unfold in real time. This is the most intensively studied interstellar object in human history. And once it leaves our neighborhood in early 2026, it will vanish back into the interstellar void, never to return. The questions it has raised will remain unanswered for all eternity, unless we solve them now. As the final images of 3I/Atlas and its fragment train flicker across the monitors of the world's great telescopes, a profound silence is settling over the scientific community. It is not a silence of clarity or certainty, but one of awe and perhaps of profound unease. For the first time since we learned to track the heavens, we have witnessed the death or the transformation of an interstellar traveler in real time. And critically, nothing about this event feels random. Nothing about it feels accidental. Instead, what the data suggests is a sequence that was coordinated, precise, and almost choreographed, as if the object did not fragment because it failed, but because it had completed a function. Think about that deeply. A comet from another star system, older than any civilization Earth has ever known, enters our solar system. It carries strange chemistry, exhibits impossible acceleration, projects organized, columnated jets, and possesses a structural integrity that defies every natural explanation. Then at the exact moment its calculated mass loss breaks known physics, it symmetrically splits into 16 pieces, not 15, not 17, but 16, the exact number required to resolve the surface area problem that had baffled astronomers for weeks. It is as if the universe itself were solving an equation it had written. And once you see this pattern, you cannot unsee it. The columnated jets, firing like thrusters, the anti-tail pointing defiantly toward the sun, the fragments radiating outward not like chaotic debris, but like petals on a flower opening to the light. The colors shift to an electric blue, as if an internal energy source had overloaded just before release. The acceleration spike that followed the breakup, as though the event had liberated not just material, but pent-up energy, momentum, or even purpose. NASA can officially label this a natural fragmentation event. Harvard can calculate the physics with perfect neutrality. The British Astronomical Association can capture the jets in stunning detail. But the inescapable truth is that nothing, absolutely nothing, in this entire event behaves like an ordinary comet meeting its fiery end. And that is what truly unnerves the astronomers studying it the most. Because if this breakup was not natural, then what was it? A self-destruct sequence? A programmed decoupling of subsystems? A release of smaller, autonomous probes? A mechanism triggered by its proximity to a G-type star? A catastrophic failure of something ancient and technological? Or something even stranger, a process for which we do not yet have a name? A phenomenon born from physics not found in our textbooks, forcing us to choose between the labels of interstellar visitor and interstellar artifact? The truth is that no one knows, and perhaps that is the realization that weighs the heaviest. As the 16 fragments continue to drift away, each following its own trajectory through the solar wind, each still producing controlled, directional jets, each faintly glowing with that same unnatural blue tint, it feels less like observing a shattered ball of ice and rock, and more like witnessing a complex system transitioning into its next operational phase. A metamorphosis, not a collapse. A message delivered through calculated destruction, a purpose masterfully disguised as random ruin. And as 3I/Atlas continues to recede toward the outer darkness of our solar system, broken, yes, but eerily functional, it leaves humanity not with answers, but with a question far older than science itself. Are we witnessing the death of a comet or the rebirth of something that was built long before we learned to look up? Because if this object truly activated itself at perihelion, if those jets were intentional, if the breakup was a preordained sequence and not a chaotic accident, then we may have just watched the first confirmed interstellar machine in human history perform an operation designed eons ago. Not for us, not with us in mind, but seen by us all the same. And now as it vanishes into the black, the only thing we can be certain of is this: we will never see it again. This was our one and only chance, our singular moment in the cosmic timeline, to witness a visitor from beyond, to study it, to understand it, to listen to what it had to say, and whatever message it carried, whatever truth it encoded in its motion and its final violent silence, it is now scattered across the void, carried by 16 silent, departing pieces. If this story has left you questioning the quiet emptiness of space and wondering what else is hiding in the profound darkness between the stars, do not let that curiosity fade. This is not the end. It is a new beginning for interstellar science. Subscribe to the channel because the analysis of these 16 fragments is ongoing, and what astronomers uncover in the coming weeks could redefine everything. Turn on notifications. Updates from the Hubble and Webb teams are expected any day now, and you will not want to miss the moment the next piece of the puzzle clicks into place. This is history unfolding in real time, and we want to hear from you. After diving this deep into the data, the images, and the theories, tell us in the comments below. Do you believe 3I/Atlas broke apart from natural stellar forces? Or did we just bear witness to the activation and execution of an interstellar mechanism older than Earth itself? The conversation is just beginning,